The net ionic equation for a particular reaction is shown above. Which of the following would be a reasonable reactant to supply the zinc 2 plus ion seen in this equation? In this equation, we have zinc 2 plus reacting with magnesium to create zinc solid and magnesium ions. In this reaction, our zinc 2 plus is the electron acceptor. In order to be an electron acceptor, you must satisfy two requirements. The first is that you do not have an electron coat, meaning there is a place to accept electrons, meaning that it is charged, positively charged. So you must have a place to accept electrons in if you're going to be an electron acceptor, meaning your outer coat must be missing. And the second thing is that you must be aqueous. In order to take in the electrons, they must be able to react with the metal that is in the solution. And the only way to do that is to have aqueous ions that can collide with the solid metal and the electron transfer can happen. So we can look at our options here and see if they satisfy these requirements. Zinc metal is a solid, and therefore it has its electron coat. The only way something can be a solid is if it has its coat. If it didn't have its coat, all of the zinc ions would fly apart because there would only be positive charges and they would all repel each other. So zinc metal is not a suitable reactant to supply the zinc plus ions. Zinc sulfate in solution is zinc 2 plus and sulfate 2 minus. So this is great because we have our ions here, we have no coat, and if you look at your solubility chart and look up zinc sulfate, it is soluble in water. So this is a good option. Soluble in water, so they're aqueous, and it's 2 plus. Zinc hydroxide is a salt, so that means it's made of zinc 2 plus and OH minus. However, if you look at your solubility chart, zinc hydroxide is not soluble in water. That means if you put it into water, it's just going to be solid, sitting in the solution, not interacting with the metal, and therefore it is not a good choice as a supply of zinc 2 plus ions. Therefore, the answer is B.